Hello everyone, my name is Maritza and today we're going to talk about the conversion of fatty acyl CoA into acetyl CoA. Just as a preface, fatty acyl CoA esters are formed in the cytosol of a side of the outer mitochondrial membrane, and it can go in two places. It could stay in the cytosol to synthesize tags or membrane lipids, or be transported into the mitochondrion for breakdown through beta oxidation. So today we're going to talk about the 4 enzyme catalyzed reactions of beta oxidation. The first one is called oxidation. And what's easiest for me, for number one, it's very important to recognize if it's losing or gaining an electron, because sometimes that could be confusing. So I wrote down oil rig here. So oxygen is loss, reduction is gain. In this case, we will be losing 2 hydrogens. In order to do that, we need FAD as a coenzyme to come in, pick up those two H's, and FADH2 will end up going to complex 2 in the ETC. And another thing is, when you think of oxidation and losing protons or electrons, you always think dehydrogenase, and that helps me to recognize which step acyl CoA dehydrogenase is a part of. And even though there's 2 steps of oxidation, acyl CoA, to me, fatty acyl, it kind of tells you it dehydrogenates the fatty acyl CoA. So anyways, moving on, once FAD picks up the 2 protons, this is the resulting intermediate, the trans 2-enol CoA. And it's also important to understand what's actually happening between here and here. So as you can see, we lose an H on both of these carbons and a double bond is produced. So that should be a key concept for this intermediate, that a double bond is produced and you get an H here, one less H on both, and they're both trans. So it's a trans double bond enol CoA. The second part is hydration, and we use enol CoA hydratase. And hydration, you think water, you're adding water, so you have H2O coming in and you have to see where it's added. So it looks like this double bond was broken again to add the first OH, and the extra H from H2O gets sent to this bottom H2. So we have a broken double bond and an OH added through the hydration step, and you get 3L hydroxyacyl CoA. And again, the best way for me to recognize, for me, when you're drawing structures, know what the former is, what the original is, and what's changed in between, and that way it'll help you be able to write out, for one, know what the base skeleton is, and then what the modifications are. Anyway, from hydration, we're going to do step 3, which is oxidation again, and we need coenzyme NAD+, which is going to pick up 2 electrons and create NADH and NNH+, since we're losing 2 protons. In this one, we're going to need 3L hydroxyacyl co-dehydrogenase, there's that word again, dehydrogenase, oxidation, and this is telling you what it's doing. It's dehydrogenating the 3L, which you know has the OH group because it's hydroxyacyl. When you do that, we can look at the differences in between those 2, and as well, NADH, I don't know if I said this, goes to the complex 1 and ETC, just a side note. And you can see here that a double bond again was formed. You can see the trend here, the double bonds are formed after losing 2 hydrogens in these oxidation steps. So a double bond is formed, a CO double bond, and that's basically the difference here. So now you have 2 ketone-like bonds, if this was a C, and that's how I'm able to recognize that's beta keto acyl CoA, keto, ketone, there's ketone, somewhat of ketone. And that is how I'm able to recognize that intermediate. The next one is the CoA thiolase, and it's step 4. Lysis means breaking bonds, and you're adding a CoA. So essentially you're breaking this bond here, adding that CoA to create acyl CoA, and you're left with this same fatty acyl CoA, just 2 carbons less because they went to this. And this cycle gets repeated a couple more times, and that is the full cycle of beta oxidation.